Okay, there we go.
There you go. Thank you.
Okay, thank you. And I'm really very much appreciative of the opportunity to join Steve Shore and his group doing these lectures. I think I've been involved in them from the beginning for some years now, so it's been a real pleasure to do that. As the intro mentioned, I've been in this business for a very long time. This is my 67th year since I'm counting my graduate studies, and which is on the same topic, basically nutrition, if you will. And I have to say, be honest about it, during this whole time, I've really been puzzled by the fact that nutrition as a science, as well as a practice, has been so ignored for so long. And so I want to talk about that topic actually today. I want to speak to it too, also from a so-called journey in classical science. I mean, science to me is really fundamental to what we learn about things. Let me just pull this down here just a second. Okay. And I have a couple of quotes here from Neil Tyson, who's the director of the Hayden Planetarium, by the way, astrophysicist, got a great book out. But in any case, here's some quotes from his book that match exactly what I've said myself. A scientist's entire mission in life is to discover features of nature that are true, even if they conflict with their own philosophies. So when further comment here on science, consider what happens when scientists disagree. We look for one of three outcomes. Either I'm right and you're wrong, or you're right and I'm wrong, or we're both wrong. Who decides the outcome? Nobody does. Think about that. That's really quite a remarkable statement, and expressed in another way that I like. I've used it a long time myself. We own opinions and we don't own facts. Unfortunately, much of the conversation that occurs in this field, I find, is more about opinions, not facts, and people don't seem to know the difference, quite frankly. As I said, I started out on, this is important for the background here to what I'm going to say. I started off on a farm. That's me on the top of on the front end of the combine, and I was raised milking cows and hunting and fishing and doing all the things farm boys do. Finally, in 1956, my dad sold the cows, and I was off to school. And so that activity on the farm, without my necessarily knowing it all that well, was fun, and for the purpose of actually producing milk and beef, if you will, and all for the purpose of getting enough animal protein. So then went away to Cornell University, did my doctoral dissertation, and that research, by the way, there was on the topic of ensuring or advancing the consumption of more animal protein. That was my background, much just like everyone else. And then after finishing that and doing a tour at MIT, I was on a faculty in Virginia Tech University, put in responsibility for coordinating a program of feeding malnourished children in the Philippines. And there we were expected to basically make sure that these kids got enough protein. But what I saw there was kind of strange. It was about basically getting liver cancer. Unfortunately, I misplaced my earlier slides. In any case, it was about seeing something there that I didn't expect to see. The children, the malnourished children, along with a few others, it turned out that the children getting the most protein were the ones most likely to be getting liver cancer. And so that's what set me on my journey. And so I just want to give that background because I come from a place not sort of prepared me for what I actually learned. In fact, it was actually the opposite in many ways. So now we're at a stage, as I say, where nutrition is so confusing. I can't imagine anything being more confusing, to be honest about it. Here's a start. If you look at the different kind of diets, I've listed a few diets here whose names are fairly well known, 20 of them altogether. There's more. And I don't understand how the public can begin to understand what nutrition is with so many options of talking about it in various and sundry ways. In my research community, we in turn add to the confusion as far as I'm concerned. We talk about individual nutrients since they have special properties, we can use them by themselves. We talk about the amounts in food. We talk about the individual nutrient recommendations and nutrient targets and even nutrient supplements, if you will. And so the medical community, in turn, ignores it, doesn't even teach it. There's not a hospital in the United States that I'm aware of that teaches nutrition. So we're going out on the wrong foot to start with, and I would argue that this combination of things I'm just showing here is really the seed for much of the confusion we now have. So another point I want to make here early on is sort of sorting out the confusion on the words that we tend to use for this arena. Diet, we speak of diet and nutrition almost interchangeably, is not. Diet is something, just a mere collection of foods regularly consumed. Foods are digested to their nutrients. They're absorbed, transported to organs, absorbed into cells, metabolized to products that function, then get stored or excreted. Nutrition is therefore somewhat different from the words diets and foods. Nutrition, I would suggest, at least that's the way I learned it and taught it for many years, is the biological expression of foods. What happens to food when after we consume it? Now, to get up to date a little bit more about these days than what I knew from before, we've got systemic problems. And I'm listening to a few here. You can add a lot more, I'm sure. But I've grouped them into environmental problems. Basically, as you can see here, we talk about climate warming, topsoil loss, so forth and so on, species loss. On the one hand, on the other hand, we've got human health issues, health care costs. We use drugs to the extent to which we're totally dependent on them. In fact, we have drug side effects, a high rate of disease mortality, shorter life, and so forth. So we've got these different sort of topics or subtopics of the larger problem, each of which suggests that they have individual causes. And then in turn, we have on drug dependency, that in turn is related, as I'm showing here, with healthcare costs, drug side effects, shorter life. And so we've got a lot of work to do. We're in the business now of recognizing all kinds of problems. We're working on them one by one, usually, as if they have single causes. I'm going to argue, in fact, that there's one broad spectrum cause, and that's something we're missing. For all of these topics here, basically, it's the fact that we don't talk about food nutrition, which in fact is turning out to be very confusing for a lot of folks, or unknown to them. And so I want to now jump to some other things that we're experiencing that sort of sets this topic aside in a way. We have the highest per capita use of pharmaceuticals in the world. We're the only country, actually I say New Zealand does too, but I was talking to a New Zealand journalist who say they have something in their Senate at the moment. They're going to get out of this, but nonetheless, the U.S. essentially is the only country who advertises TB prescription drugs. So we use a lot, we advertise them all over the place, but yet on the other hand, prescription drugs have side effects, believe it or not. Drug side effects is either number 3 or number 4, depending on how you count them, but as a third leading cause of death, data that I'm familiar with, right behind heart disease and cancer, something a few people know. We are laden with the use of a lot of drugs to solve problems that need not exist in the first place. And then we turn around, taking all these drugs, we have to live with side effects. It's third leading cause of death. Life expectancy is something that is from the top of the news that I hear, is been misrepresented. Our life expectancy beyond 65 years is way down the list. In fact, among Western countries, affluent countries, if you will, we're in last place for life expectancy from birth onwards. So we're not doing very well. And of course, at the same time, we're living with this rationale for using drugs and not understanding nutrition. So put all that together, we've got confusion, we've got consequences. and we somehow are not looking at this thing in the right way. So what explains all this? I want to go back to one of my favorite places to start this discussion is in the discovery of protein. Protein was discovered in 1839 to be specific by Dutch chemist Gerhard Mulder, and he named it after what he was doing. He was doing a research project with a dog, at the time, and he found that the dog didn't have meat; it didn't live. It's quite surprising, I suppose. But he wanted, as a chemist, to isolate in the meat what was so special about keeping that dog alive. So he needed the name. He named it after the Greek word proteos, which means of prime importance. So that's where the name protein comes. That really is quite significant, the discussion we want to have here, because protein is almost a premier nutrient that we have in terms of affecting our thoughts on food consumption over the years. It's been the driver to a great extent of the kind of food that we tend to consume. So the question is why? One way to get a peek at that sort of question concerns the way we have operated with the consumption of protein, especially animal protein. It basically strongly relates, as these World Bank data show, to income producing potential. Not surprising perhaps to most people, but when we get enough money, the first thing we want to do is to get animal food. It's that simple. I've worked a lot in China and countries around the world, and I can tell you that in the countries that don't consume much animal protein, probably because of poverty for the most part, they can't wait to get their hands on protein because they're associated with affluence, like we in the United States has. And so this chart here was put out by the World Bank. I drew the line myself, just to sort of making sure that there's points on both sides of the line, if you will. And you can see it's basically a straight line almost. As soon as we get protein and then it's when we want to consume, as soon as we get money, we want to consume protein. So have money, eat high quality protein. So what is protein quality? That has actually consciously as well as unconsciously driven the conversation about food and about protein in particular throughout this last century, as a matter of fact. High quality, what it means is that more dietary protein is of the protein we consume, more is retained. And we call that in science biological value. And we eventually called it high quality because it concerned the protein in animal foods, not plant foods. And so when we consume animal foods, a higher proportion of the protein, in fact, is retained by the body. And that was thought to be a good deal. But on the other hand, if you look at it somewhat differently, we're animals just as well as other animals. And so when we're consuming their protein, we're getting protein that's more or less similar, very similar to ours, and it gets absorbed better, faster, and more is retained. And that was thought to be a good idea. It's not really. And so animal protein has higher retention, more quality. Plant protein is lower quality, lower retention. And that research was done in 1924 by a man by H.H. Mitchell, a professor at the University of Illinois. And when I did my doctoral dissertation in the 1950s, I was well aware at that time of the fact that Mitchell had a very big name. And we were working with the concept that animal protein is better than plant protein. Thus, we called it high quality. But over the years, there has been an interest in not disturbing this idea of animal protein being the premier nutrient. And so in more recent years, and we did this in our lab as well as some others, we learned that retaining more protein actually does some other things. It increases the growth hormone, which in turn stimulates the development of breast cancer, among other things. It also increases circulation of blood estrogen associated with cancer as well. Free radicals, which has a mischievous way of doing things, all kinds of diseases, increases cell mutations. In other words, we retain more protein and we have to suffer these problems, all of which lead to cancer. And I must tell you, this is in the last 20, 30 years or so this has been done. Still today, the scientific community does not recognize this. They still want to call it high animal protein is high quality because of the fact that it just stimulates growth, quite frankly. But at the same time, it does all these things as well. It also increases cholesterol. Back in the early 1900s, when blood cholesterol was first linked to heart disease, there was an interest in understanding, what causes cholesterol to go up in our blood. And the early research showed that it was animal protein that caused it to go up. But then there was a bunch of studies that went on for the next 15, 20 years. And eventually it was concluded with a great deal of certainty that the chief cause of heart disease is consuming animal protein. It's not saturated fat. It's not total fat. That's a discussion for another time. But in any case, it increases, in short here, as you can see, consuming animal protein increases cancer, increases heart disease, and increases diabetes, by the way. It increases blood sugar, A1C, which is one of the measurements that we use to detect diabetes, if you will. In any case, this kind of information here that basically is suggesting that higher animal protein increases all three diseases and many more, and we have mechanisms for it to explain it, basically has been canceled out. Nobody wants to hear this. When I say nobody, I'm talking about the people who basically are funding much of the research and selling products. They don't want to hear this, but this is what is very well established. So I've come up with a rather simple dietary recommendations. I'm quite familiar with the enormous, infinitely complex systems that sort of control what happens to the nutrients we consume. And it can be extraordinarily complicated and confusing, as I already mentioned. But in any case, I've narrowed it down to two things, because I think one way to deal with going forward on this is to make it simple if possible, but at the same time, honor the complexity. In other words, it's terribly complex. Complexity, by the way, with all kinds of things, thousands, hundreds of thousands, millions of different entities can be picked out one at a time, and we learn something about it. We tell the public, and we can make any story we want, quite frankly. But there is a very simple way of looking at the total sort of umbrella effect, and that is simply to consume plants, not animals. To get into that more in a moment. So, and plants, by the way, simultaneously offers all the nutrients we need at this, more or less at the same time. One other point too, when we tend to consume animal food, plant food goes down because we consume for calories. We want to get a certain calorie intake. And so as we increase the proportion of calories from animal food, we decrease the proportion of calories from plant food. So when we look at various kinds of data, we have to keep that in mind. We'll see something related to one or another thing, but we have to keep in mind that there's more than one thing going on. There's lots of things going on, especially in human studies. So now let me come back to the results that I was involved in the Philippines when we learned, in fact, that these children who consumed the most protein also had the highest, apparently, the highest risk for liver cancer. And so that was also shown in this study here in 1968 by an Indian group with experimental animals. They showed that animals had 20% of total calories as protein. And by the way, the protein being used in this case was casein of cow's milk. 20% being consumed compared to 5%. Then in these animals, they were predisposed to getting liver cancer. What they were able to show is that to 20%, that's a high level of protein, regular levels, I say here, but experimentally, that was a higher level. 100% of the animals got the cancer, and the ones given lower protein, none did. I mean, it's really a striking difference. That's in turn what led me to come back home, since we were expected to give protein to these kids, higher and animal protein at that, and that kind of result came out. This is really what started my career in basic research in nutrition. And here's a little chart here showing, for example, the relationship between the cancer formation, this is early cancer, over the first 12 weeks, if you will, when an animal starting with the cancer has already been started, there's a gene been mutated. So in any case, during that time, we found that they have animals 20% protein, They grew well. Was feeding lower levels did not so good, do so well. Um, exactly what the Indian workers have found themselves. Then we did something else that was kind of striking, namely, as I wanted to see whether or not it was hard to believe this, by the way, because of my own background, that animal protein was actually causing cancer. So we decided to do this little trick here, and that was to see what might happen in the early stages of cancer development if we change the diet. So starting out with 20% protein, the cancers were growing well, turning it off by lowering the protein, back on again. In other words, we could turn cancer on and off just simply by regulating the protein intake, animal protein intake in this case. Plant proteins did not do this. It was very striking, as you can see here. And very quickly, just in 3 weeks' time, you can see this kind of change. It was really about cancer reversal. And this idea of reversing cancer or serious diseases like this really did catch my attention, because what we're doing here is reversing cancer by nutritional means, really striking. So it also suggested something else too, that for those days, that it's not the genes that really determine cancer. They start with genes, they start with that information. But as cancer grows and related diseases like this, that's really a function of the kind of nutrition that we're consuming, the kind of foods we're consuming. So it's nutrition rather than genes that primarily control cancer development. That was published in, they say in this paper here with my students. And as I said before, the soy protein, wheat protein, which we tried 2 plant proteins to see if it had a similar kind of effect, it did not. This is specific for the protein of cow's milk, and later it was specific for related conditions just from animal protein in general. So then at that point in time, you get something striking like this. It's not believable. Nobody wanted to believe this. I was in that group in a sense. One of the things that you have to do in something that's really potentially controversial like this, determine the mechanism of the effect. And we call that in epidemiology biological plausibility. In other words, we're asking the question with something like this so striking, is it plausible? And so we look for the mechanism of the effect. And one of the reasons we do that too, to look for the mechanism, is to see what kind of drug we might use, if you will. If we can identify the mechanism, we can maybe find a drug and block that event, and then continuing on what we want to eat. So that's what was another purpose for a lot of folks in this business. So here I'm showing you just 2 representations of the scheme of cancer formation that we tend to work with in research. In other words, cancer, just for this arbitrarily, we divide it into 3 stages. The initiation stage, when cancer is forming, and then the promotion stage, when it's being progressed along over years, in some cases, in the case of humans, and then the final stage where cancer is migrated elsewhere. We have metastasis, if you will. And so we have this very simple sort of scheme to study things. And so we started out to find this mechanism by looking first at the first stage to see what effect protein had on a bunch of different so-called mechanisms. And it turned out, all the ones here, I won't go into the details of what's here, but basically the high protein diet increased the rate of the carcinogen into cells. It increased their metabolism in such a way, and that increased in 2 ways, increased their metabolism in such a way they formed a product that then bound to the genes, the DNA specifically, and eventually that would translate into more cancer cells. And so we found a bunch of mechanisms here in the first stage, and one of them, it actually decreased the one that was good. In other words, when we get the damage of the DNA occurring, that can help to lead to cancer, the animal protein actually decreased it. So it increased all those things that increase cancer and decreased the one that is meant to protect against cancer. So then we turned our attention to the second stage, if you can see here, that had some more. And eventually I got to a point where after some years, about 12 to 15 years, and that was all driven for the most part by having students who wanted to do a doctoral dissertation, doing research. And so I was doing it almost nonchalantly, just one thing at a time, looking for that mechanism, if you will. After a while, all of a sudden realized that after 10 mechanisms studied with a great deal of thoroughness, 3 or 4 years, if you will, what I learned was that 8 of those 10 mechanisms increased in activity with a high protein diets, 2 decreased in activity, but lo and behold, that combination of 8 increasing, 2 decreasing, basically all 10 worked in unison to increase cancer. That gave rise to another thought, and that was basically the whole idea that nutrients tend to work together in cells. In this case, and they also, as a nutrient comes in, it works by multiple mechanisms at the same time. So, and the original purpose of this, in a sense, was to discover a mechanism that might lend itself to the development of a drug. There is no such thing. In fact, it's really undercut my notion and the notion of a lot of people in pharmacology that we tend to want to find a specific mechanism and then treat it in some way to stop the disease. That's not the way to do it, because it turns out, as you can see here in part, and with other research too, nutrition works by many nutrients working together and working by multiple mechanisms, if you will, which we call biological plausibility. And that is really what nutrition is about. This is the distinction, simply put. This is this distinction between trying to control disease, even reverse it and treat it, versus use of nutrition to do it, versus the use of drugs. Nutrition is far, far better. That's nature. That's the way it works. Other nutrients do the same thing, and they operate not just on this kind of cancer or other kinds of cancers, but a whole variety of different kinds of diseases. It's one big cloud of effect, almost, if I can put it that way, of mechanisms and nutrients working together in a marvelous way to affect a lot of results that turn out to be the same. So I'm just showing here a little scheme of what is involved here. This is a sort of my little biochemical schematic of what I just said. These are 2 cells, right? And the carcinogen comes into the cell and eventually it gets metabolized and binds to DNA, and then it can be repaired, and then it comes down and comes into a new cell as the cell divides. And anyhow, all these little stars are just little symbols indicating the 10 mechanisms that we discovered. These 4 in the first cell, the 4 in the sort of daughter cell, they all increase cancer because they increase in activity and they increase cancer. Here's the 2 that, in fact, the high protein diet actually blocked this. This is good. Our body normally wants to repair this kind of stuff, and it goes on at a great, good pace all of our lives. But the high protein diet actually decreased this. And then daughter cells, when they come along, it actually block the formation of another immune cell that's used to actually kill this is what we call natural killer cells. Later, this is called T cells in modern day. But in any case, the high protein diet, you can imagine, 10 things it's choosing to do, and I'm sure there'd be far, far more if we just had time to go and look at them. What it showed me was that the high protein diet is doing a lot of mischief according to a lot of different mechanisms. So that's the way that I see nutrition working. It's not one nutrient, we're doing one thing at a time, affecting one particular disease. That you can see short-term effects sometimes with that approach, but in terms of long-term health, that is not the way to do it. It's a source of immense confusion, as I mentioned before. Now, I want to show you another sort of angle on this perspective, of nutrition being very effective in terms of controlling more than one disease. I'm going to show you here a series of plots, graphs, if you will, that were published during the last, I think it's, since 1959, wherever that is, just the time I was a graduate student, I guess. These are studies by other researchers showing something really interesting. And I just went back and collected this information here maybe 4 or 5 years ago to see what this looks like. Basically, here's a case with kidney cancer on the y-axis, an amount of animal protein consumed. This is, as I say, another research had nothing to do with this. And this is a list of all countries, a group of countries on this chart. I drew the line through there, regression line, using a sort of algorithm that was permissible. You can see that there's almost a straight line relationship. The higher the animal protein intake, the higher the kidney cancer rates. That's really impressive. and I want to say too, that'll never be shown to be the reverse. I mean, there's too much data here to imagine something being reversed. So more protein, more kidney cancer. And here's another one. Here's one more. This was done in 1959 on heart disease. This again is a bunch of countries, if you will. The higher the protein intake here on the x-axis, the higher the heart disease rates. That's equivalent to the discovery that higher protein, the higher cholesterol levels was associated with a protein as well. This is animal protein. So then we go to another. This was done in the 1980s. If you will, this is prostate cancer and non-fat milk. Look at that, is really impressive. Again, a straight line relationship, almost coming down to this XY origin, if you will. Higher consumption of non-fat milk, more prostate cancer. And there's been quite a lot of research done on that now, and people tend to want to ignore it. But non-fat milk, by the way, doesn't have fat for one thing, obviously. It doesn't really have any sugar, and the only other thing that's left for energy is protein. So I regard this as an indication of animal protein effect. Higher animal protein consumption, more prostate cancer. Again, that is so impressive. You see lines like that with a wide range of data for countries around the world. That means something. Here's one for breast cancer deaths. This is a friend of mine from Canada who actually was measuring at that time, and he didn't think about the animal protein question at that time, but he was distinguishing different things about the diet with respect to breast cancer cases. He was looking, for example, at saturated fat, which is primarily an animal food. In fact, the correlation between saturated fat and animal protein is almost perfect. So this is another indication that rather than saturated fat being responsible for this, it's really animal protein. Here's the United States up here near the top. Again, straight line relationship to go right down through the origin. And I keep pointing out this idea of these lines going down through the origin. What they suggest in theory, more than theory, actually, what they strongly suggest is as soon as we eat any animal protein or animal protein-based diets, as animal protein goes up, plant protein goes down. Of course, I said that before, but as soon as we start consuming that kind of diet, typical of the American diet, we start to get these diseases. I don't see how that isn't so impressive that it should be making front pages of the newspaper. These are, as I say, studies done by others. Here's one a little bit different in this case. This is cholesterol intake on the y-axis and heart disease on the bottom axis. But this is, again, shows the same thing. The amount of cholesterol we consume is representative of the amount of animal protein we consume. In fact, it's been known that the amount of cholesterol we consume does not necessarily have much to do with the amount of cholesterol in the blood. There's lots more going on than that. So what it shows is increasing cholesterol intake, or let's say protein, we get more heart disease. Again, a really straight line relationship. And that was done, I forget what year that was. Here's one from colon cancer. Look at this. This is meat intake on the x-axis, on the y-axis is colon cancer. So the higher the intake of animal protein, again, animal-based diet has all of these. Uterine cancer, breast cancer, prostate cancer, 3 cancers of the reproductive tract. What you can see here, the same thing again. So here we have all these charts that were done before, and each of these researchers, I knew some of them, never took serious consideration of the fact that this was really animal protein. They called it maybe non-fat milk, or they called it meat, or what it was, cholesterol. But what we see in all of these is basically the same information, irrefutable. No one will ever come along and research and ever show the opposite. This is far too much data for that to be something different. So I thought that was really quite impressive. I call those things that being measured by other means, cholesterol, which is only in meat itself, total fat, low fat milk, saturated fat. Those are all representations of animal protein intake from animal protein surrogates. Now, here's what I just wanted to throw in here by one of the previous researchers who actually was looking at the relationship between unsaturated fat. I changed it here to plant protein, but we looked at the relationship between unsaturated fat and breast cancer and found no relationship. Unsaturated fat is typically present in plants. So when they consume more plants, you don't see any relationship like you do with animal food. It's so striking. It is so striking. Now I want to move to another thought. And first off, is the animal protein effect itself, when it's consumed with other foods, of course, they all tend to work together. And even one nutrient, like animal protein, for example, has infinite numbers of mechanisms by which it works in the form of a cloud, like together with the other nutrients, they're all doing the same thing. So we had these data I just showed you, human studies showing the relationship. And now let's take this forward in more recent times. In this particular case, in the food and dietary guidelines that were developed in about 2000. We develop dietary guidelines every 5 years, revise them, look over again. A group of scientists get together and work on any update information they might like to have. But it's really run by the United States Department of Agriculture, who's beholden to the livestock industry, by the way, coupled with the Department of Health and Human Services, which is coupled with the use of pharmaceuticals. So those two cabinets in the president's cabinet, agriculture on one hand, Health and Human Services on the other, basically get together and decide every 5 years what should be the dietary guidelines for the public information. I want to show you here something in 2002. I know this very well, quite personally, quite frankly. And so what I want to show you here to make my point is that the dietary protein consumed in the United States as a percent of calories, you can see here, I've broken it down in this way to show you. First off, this was long ago determined that 5 to 6% of total calories is the minimum amount of protein needed. I mean, protein is an essential nutrient. Make no mistake about it. We need it. No question about that. But only 5 to 6% of calories is all that's a minimum requirement, they say, if you will. We recommend, though, around 9-10% or so. That's a recommended daily allowance, and that's enough protein for everyone, right? But in reality, here's what we do. And by the way, these dietary recommendations were started in 1943, so we've had a long time working on this kind of thing. So with the fact that only 9 to 10% of the protein being recommended on a daily basis, unfortunately, the public didn't go along with that all that well. We like our meat and eggs and milk and so forth. And so we were eating protein within this black range, and this is the range of protein intake for the American population. All of it basically in excess of what we really needed. 75% to 80% of that protein is animal-based. So we're basically consuming protein at a level far greater than we need, number one, and 75 to 80% is animal-based. That's quite striking. So we're way out of whack in a sense. Now, I want to compare this range here of normal intake, if you will, versus this little chart up in the upper left-hand corner, just a capture of the previous slides I showed you. Those increases in disease occurred in protein intake ranges right during this period here. In other words, those charts, those lines start right here when we can get all the protein we need from plants. We start adding animal food, and here come our diseases. Overlaying what we normally do. So we do this, a lot of us are up in this territory, we get more heart disease, cancer, and all the rest. And so I'm just overlaying that with this. Let me show you the real punch line here. Oh, by the way, whole food plant-based diets, by the way, provide enough protein. We don't need it more than that. Although plants can have much higher levels, can go up to 20 maybe, or even higher. But that's no consequence, because that does not increase cholesterol, does not promote cancer. So, but using animal food, on the one hand, we get this kind of chart here. Now, in 2002, that committee at the time decided to establish a so-called upper safe level for each nutrient. And so they did it for a variety of nutrients in that report. So they decided that 35% is upper safe level. In other words, this is nothing more than an ad by the government, in this particular case, basically under the control of industry, but an ad to consume as much animal protein as you can get, all the way up to 35%. It's total. I mean, I think most of you may not be in science as such, but I should wonder how in the world could that happen? How in the world, we already know, for example, that diseases go up, serious diseases. Most of the deaths we die of prematurely are these diseases. Now they're saying we can go even higher, up to 35%. I have to say it's total nonsense, but that's what we're living with. That is now in the registry. And there it is. I call it mob power because I can't think of any other word that describes this. It's basically a representation by the Dietary Guidelines Committee, done by the Department of Agriculture, in particular, livestock industry. Somehow they got in there involved. I know how they got involved. I know personally how they got involved. I know what they did. I know very well, and I'm basically going to save that for another time, because it's a representation of how we, the public, have had to live with information that's not accurate. So here we are today. And I get, as I say, kind of depressed about this because I found science to be very exciting going through the years. As long as we, did it like it was told we were supposed to do it. You can have different opinions. That's great. You can bring people with opposite points of view together, have discussions out in the open. At the end of the day, we're subject to peer review, and that's where it's been. So I think we've been making progress. But here, all of a sudden, just announced there just about a week ago, I think it was, this new report, 296-page report by the Food and Agriculture Organization of the United Nations. Now, for those of you who may not know, FAO is the agency of the United Nations that looks after agriculture, as it obviously says here. Okay, they came out with a report. Here's the title. It says "Contribution of Terrestrial Animal Source Food," that's animal food, to healthy diets, to improve nutrition, health care. Now, I cannot overstate the importance, the significance of this particular report. Coming on the heels of what I just showed you. Here's a very powerful agency, in the business of developing science, so to speak, for the animal food industry. And this is worldwide. So it has an enormous audience around the world. It'll become the standard, going on with the idea that, we can eat a lot of animal protein and no problem, which is false. So what did this chart show? I'm just showing you in their key findings. And I'm quoting here exactly. They call it terrestrial animal source food, or TSF. And these are actual quotes, and I'm putting some dots in the sentences here that weren't germane to what it said, but this is animal food here, meat, milk, and eggs, if you will. It says it can make vital contributions to meet the global nutritional targets of 2025, endorsed by a couple other organizations, World Health Assembly and this group here, and it's aimed to reduce stunting among children under 5. I just cannot find anything that's more offensive in a way by saying that sort of thing. That was the argument used way back when I was working with these stunted children, if you will, in the Philippines. And the stunting comes from the fact that these children in those poor countries, they basically didn't have enough food to begin with. That was a big thing. And secondly, they were exposed to a lot of infectious diseases at the time, being, not very well, you couldn't handle that. And so, and they had so-called stunning that went on into lifetime. So now they're talking about, using animal food to reduce stunting in the children, as if that's what we're all supposed to do. This kind of food too provides higher quality proteins. This is sheer nonsense. I showed the data here that others don't seem to want to talk about. High quality protein, there's no such thing. That they say is basically animal food. That's why they use the term, because they're not aware of this. And also, as they want to say, this is the key find is the summary part of the big report. These foods here says counteract the effects of anti-nutrients found in plant-based foods. They're reacting to the idea that I think particularly because of me, because I spoke to the FAO myself. I was invited to speak there. And they're very conscious of what our China study has been doing. So they now want to talk about the anti-nutrients in plant foods. Of course, if you take certain things out of plant foods, you might find they're not exactly desirable, but not the normal food without the pesticides, herbicides, and so forth and so on. They say basically what they're saying here is that these animal foods counteract effects of this. This, again, it's just sheer play on words. And then the worst of all, these animal foods, so they say, can have effects on NCDs, which are not just a heart disease, cancer, diabetes, immune function broadly, and even I mean, I wish I could have 4 lectures in this case here, but all of this here stuff is taking advantage of the public not knowing nutrition. And they put together this major report for all the countries around the world to use to put in their national guidelines. So now I want to turn your thoughts to just one more thing. So I'm at the point right now, we simply don't need animal food, in spite of the fact that's the way I was raised, in spite of the fact that I was doing a doctorate dissertation to promote it. I live by science. And that's why I showed you in the first place, because science to me is a really amazing sort of concept, by which we can have different opinions, of course, but we have to get together and then trade ideas. And then in that course of trading ideas, we get whatever we might conclude. We submit it for publication. We get reviewed by professionals, and then eventually gets published if it's done right. Anyhow, so no protein. There's a second thing here, as I said, it has to do with this concept of whole food. Here's what I want to develop this thesis here this way. This is a chart of reactions going on in cells, all cells, plant and animals, charts in cells that is capturing the energy from the sun. All of the energy comes from sun, by the way. And it all comes in by the way of plants, not animals. It comes in by the way of plants. So the plants capture the energy, and then the whole series of reactions going on here. This is called the glycolysis cycle or Krebs cycle down here. And so it's sort of managed step by step all the way through here, kind of peeling off little bits of energy here and there. And this is fairly fundamental biochemistry. I taught this about 50 years ago myself. It was very exciting at that time. It wasn't quite as complicated this, a little simpler, but it was all quite exciting to see that the energy we get for our lives comes from plants, only plants, and then it's gradually extracted down through the course of all these reactions. This energy is picked off and sent here, there, and every place to serve our bodies. So that's basically the energy cycle. Then it turned to this, and now 10 times worse. That simple reaction, and just in the years during my career, has now grown so immensely. As I say, it's 100 times what I was looking at in the 1960s. So here's the maze, I call it. And so a drug, to make a drug, the idea is there to find one reaction to create a chemical to block it, if you will. That is the drug industry. In fact, it's one among many. That's why there's so many side effects. You can just imagine for a foreign chemical to come in with oftentimes quite toxic, to come in the cell and find one thing that's going to solve our problems with our disease. It makes no sense. On the other hand, the food protocol, you got multiple nutrients. There's no side effects really when they're consumed through food. It's addressing all these at the same time. That's really what it's doing. I'm jumping ahead and not defending my proposition very well, but in any case, there's the what means of improving human health and controlling problems. We can either use drugs, one reaction at a time, get side effects. Thirdly, you cause the substance. Or we can use food without side effects and just eat food. There could not be more dramatic in a sense. So now I'm going to show you here this repeat of this chart. I simplified it down a little bit here, if you will. In this case here, I'm going to talk about a real event, how this occurred. Cholesterol, as you all know, has long been considered to be a cause of heart disease. It's not, by the way. It's an indicator of heart disease, yes, but the cholesterol we consume doesn't necessarily relate to that. So the idea arose during the 70s and 80s or so, especially during the 80s, that if we could find in this chain of reactions the source of cholesterol, maybe we could block the production of cholesterol because we thought cholesterol causes heart disease. We can block it in some way. So they found eventually it worked out the biochemical mechanisms for forming cholesterol, and it goes through a series of steps. Here comes from this compound called acetyl-CoA, called centerplace, but in any case comes from here. cholesterol. So they found a place, they find one of these steps in here where, a drug might block it. And they said, wow, that's great. Now we can block cholesterol and don't get heart disease. So simple-minded. And here we have statins. Now, what is it, a 26 or $27 billion industry in the United States? Incredible. And really, the evidence, if you look at the evidence of statins, I've looked at quite a lot of that. At best, it might reduce heart disease by 9%. A lot of them don't show any effect at all, and it has side effects. So that's what we live with. Here's another example of living with this idea of working with drugs. That starts with Nixon's 1974 or 71 war on cancer. At that time, the idea in that war on cancer was to really put a concentrated effort in synthesizing chemicals to control cancer, reverse cancer, treat cancer, if you will. That was 71. 30 years later, 2071, in 2004, we then, by that time, had a lot of data, a lot of cancer patients who had died of cancer, stored here in the United States especially. And so they went back in 2004, some researchers did, Australians in this case, Australians and Americans, but they went back and looked at all that data, hundreds of thousands of subjects and representing 22 different cancers. And they looked at the drugs that people were taking and then determined how effective they were by indicating their effect on 5-year survival. All those drugs basically actually increased 5-year survival by only 2.1%. That's the cytotoxic chemotherapy drugs that have been used all this time. Besides, many of them they cause cancer themselves. That's what we've lived with in the cancer field for 30 years. That's really very damaging information. And many of these chemo drugs cause cancer themselves. The average cost in 2014 is much higher now. It's over $1 billion, well over $1 billion, probably a couple of billion by now, to make one cytotoxic chemotherapy drug. Can you imagine? They don't work. And they're good business, great business. How many of us know? Here's one more example of this idea of working on the single things, like a single drug or a single nutrient, if you will. I found this really interesting. This was published in 1981. At the time, I got to move a chart away from here. You can maybe see it. In 1981, and what these researchers had done at that time was they looked at the relationship between cigarette smoking and lung cancer. And here's a three-way chart, if I can show it this way. And what they did along this axis here, they got the amount of smoking occurred, and they divided up these people that they had in the study into those who did not smoke, those who smoked for less than 30 years, and those who smoked more than 30 years. And you can see here with this more than 30 years, they're the ones who got the lung cancer for the most part. But then they added one more thing to this group. They just sort of determined, I don't know why they wanted to do this, but they determined in this group here, how much beta carotene we're consuming. And you can see that it's here. And so the higher the beta carotene, in this case, oops, I got problems with the higher the beta carotene, smoking, deaths from smoking cancer went down dramatically. These are people, all of whom are heavy smokers, all of whom are heavy, or at least smoking for more than 30 years. And those who consume more beta carotene, look at that, really impressive dose response relationship. Can't get much better than that. Now, beta carotene, as you know, is from plants. So what they're really doing was measuring plant consumption. Not all that great, probably, but enough that caused a dramatic decrease in lung cancer. Then they went on to beyond that, said, this is exciting. Maybe beta carotene, maybe if we could develop the beta carotene into a pill and give it to these smokers, we could reduce lung cancer risk. So this study here was organized, I'm going to describe in a moment, just did a study. This was Finnish and American researchers. They had a total of 29,000 male smokers, and they wanted to follow them up for 8 years because they thought that it was going to take 8 years to see the effect on lung cancer. And actually, they saw some effects as short as 5 years and had to quit the study. Their hypothesis was that beta carotene would actually previous chart showed, would decrease lung cancer. What they found was in this study, they were able to calculate food beta-carotene intake, reflection of plant foods, of course. What in 5 years' time, they found that, yes, just like the other study did, it decreased lung cancer and was statistically significant just within 5 years. But the people taking the beta-carotene supplement increased lung cancer by also significant increase, just the opposite. This demonstration here, I was at the time very much involved in some of this kind of activity. I just found it staggering. In fact, I served at the wishes of the National Academy of Science and in the court hearings on claims being made about supplements. And I became aware of this at the time. And supplements, bottom line, is supplements don't work like they do in the nutrients in supplements do not work like they do in food. In fact, they're really problematic, can be the reverse. It may, in the first short period of time, a few months, a year, or something like that, look like they're doing something good. No, long range, supplements are no substitute for food. I call food holism and use the supplements reductionism. In other words, holism, everything working together. That's nutrition. Reductionism, which is the feature of the entire medical system, is drugs. So holism is a reflection of food or nutrition. Reduction is a reflection of working on one nutrient at a time, one cause, one drug, if you will, one supplement maybe. This doesn't really work. Here's some more examples. I've watched this evidence accumulate over the years, and here's some things that are kind of ignored, but they're published. Vitamin E increases hemorrhagic stroke by 74%. That's another example of what I'm talking about. Calcium and vitamin D increases. You can see here these things here. There's a lot more evidence of this kind of thing that doesn't get publicized very much because the supplement industry would be upset, quite frankly. I just see this leading to a second proposition, namely, eat plants. Yes, stay with plants as much as you can. The more you do that, the better it gets, because if you stay with the plants, just eat only that. I know that a lot of people find that difficult, but if you stay with it for at least 2, maybe 3 months, and we got really good data on that, by the way. If you stay on that period of time, your body tastes have changed. You don't want to go back. So you're giving your body a chance to actually become accustomed to this food you might not want to have used. And by that time, you love food, your health changes, cholesterol's down, and all these good things begin to happen. So I talk about nutrition being a holistic concept, multiple nutrients in the food working together, hundreds of thousands and more, multiple mechanisms for each nutrient, a whole host of diseases. I mean, cancer, heart disease, diabetes, autoimmune diseases, thyroid problems, whatever. They all seem to respond to varying degrees to the same proposition. Eating plants, have good variety, and then not adding back a lot of substances like salt, sugar, and fat. Those are not real plants, obviously. We become accustomed to that because those 3 things, salt, sugar, and fat, actually enhance taste according to most people. But the problem is, a little bit here and there, I suppose you can't say it's, and it definitely cause problem, but we tend to use more and more, and we become addicted to the taste. That's the problem. But if we try to stick with a whole plant foods, a whole food plant-based, and stay there, that's the way to go. That's been documented in the book Whole, which is a New York Times bestseller. And then it stands in contrast. This idea of nutrition working that way stands in contrast with what I call medicine, or better yet, reductionist medicine, where we talk about one disease at a time as if it's an entity unto itself, and shares no relationship to any other disease, which is incorrect. But one disease, one cause of that disease, one mechanism to treat that disease. That's what medicine is. So that leads to the concept of targeted drugs that have side effects, as I've already mentioned. This is why holistic nutrition, or just nutrition, but nutrition is really holistic. This is why it's not taught in medical schools. I've lectured in medical schools in all but 6 states in this country. And I know pretty well the way they think, or not in the medical schools or conferences. I know very well what drives our medical system. It's all about focus on one disease, one entity, one treatment, one this, one that, and it's not doing us really any good, in my view. Maybe some places somewhere along the line, but not in the whole. If nutrition is taught, less need for drugs. This is why the public is so confused about nutrition. They'll never learn. First, nutrition is just talked about in terms of individual nutrients, as they say, how much is in food, or how much you should put here and there, how much you should consume, all those details. And it's changing. It's changing over time. And those numbers are changing. How in the world can anyone really remember that? When in fact, a very simple solution would just be eat plants and try to eat them in whole food form. But the medical system is not going to allow this, because the medical system is designed to sell things and make money, not make nutrition. One more comment here. This is a list of diseases I put together a few years ago on to make a point that the whole food, plant-based diet, can prevent, suspend, and or cure all these diseases. This is just a collection I got out of the literature. It's a good list there. It's very broad. It happens rapidly, and there's basically no side effects. What about viral diseases? I didn't have that access to that information at the time, but subsequently did. In fact, we did a study in China. Many of you may know about, a very large study. That we looked at a lot of effects of water, nutrients, and other characteristics concerning health on the production of about 4 dozen different diseases. One of them was a viral disease. Well, actually 4 were viral diseases. But this is the one here that kills about 800,000 people a year worldwide. It's the 5th leading cause of death in the world. We don't hear much about it, almost nothing, in the context of the coronavirus thing. But in any case, just show you a little scheme. I went back when the pandemic broke. I went back to the data we had at that time. It was 2020, and this was a combination study between mainland China and Taiwan. And had the data, and it was told about almost 9,000 people in that. We measured what they ate. We took blood samples, and we knew what they died of, and so forth and so on. And this is just a sort of a brief schematic of the point I want to make. Namely, we have a virus out here. This is a hepatitis B virus called surface antigen. It's a live virus, if you will. It's out here in the community, if you will, and it lands on us, and everybody can get infected with it. That's not the issue. And it can stay in our bodies and be asymptomatic, if you will, or it can do its dirty work, form liver cancer. Otherwise, when it lands, if we are in the right condition, we can form antibodies and T cells, by the way, and we can do this kind of thing here. So what we learned from that exercise, we had lots of nutrient characters. We measured all over China, 170 villages, to be honest about it. So this is publication information. So what did we learn? The virus comes in, infects us, and we let the active virus hang around. That's when, another way of saying this, that's when we test positive for the virus. It just stays there. It does one or two things. One, it causes just problems. In this case, liver cancer and death. It's a very high rate of death with this particular virus. And it turns out that the single factor, according to 11 different ways of measuring this kind of intake, all highly significant for the statisticians and a bunch of P001. So I just used those. And it turns out when in this population of 8,900 and some people, that they're consuming only a small amount of animal food are the ones who actually got the liver cancer. In other words, they do not need to what was needed. And that was consumed plant food. The ones consuming even tiny bit of animal food, they got the death. The ones consuming plant food, the virus was turned into be an inactive state by formation of antibodies. And I should say, that's enhancing natural killer cells, T cells, along the way. So animal food, surprisingly small amount, only 10% of what we do on average was in this. Plant foods, on the other hand, they did not get the liver cancer. Animal food people got liver cancer, plant food people did not. Really striking. And as I said, these are all highly significant risk factor correlations, conversion to the same outcome. And of course, that has not been very acceptable. I published a lot of papers, just well over 300 and some papers in peer-reviewed journals. I've served on editorial boards and done all that sort of thing. I submitted this information at the beginning of the pandemic, suggesting that, gee, what works here on this virus here might also work for the coronavirus as well. Something happened the first time in my life. It happened twice. I've never seen this. I sent it into the two leading medical journals in this particular case. Both of them would not even review it. They would not even that never happens in this trade. I mean, publication can be turned in if it has nothing to do with what that journal is publishing. But in this case, these are two journals, medical journals, very much into encouraging all the information they could give on the coronavirus. They turned it down, primarily because the companies own these journals now. And this is where it really depresses me, because science used to be a great discipline, how we learn things. Now it's coming under the control of industry, particularly the livestock industry and the drug industry, if you will, among others. And they say they don't want to hear this kind of thing. They don't want to hear that, for example, the virus might be controlled by just eating the right food. And it can happen very quickly, by the way. And here's a quick summary of what we do know about the individuals most susceptible to COVID-19. These are people over 60 years of age, and they're the ones that comprise most of the deaths, as you know. Degenerative diseases, diabetes, obesity, heart disease, so forth and so on. That's where most of the people who supposedly died of coronavirus were actually dying of these diseases, quite frankly. And I'm showing this little scheme here. Had these people right here been used the right nutrition, they wouldn't be having these diseases, and therefore be susceptible to the COVID diseases, especially the severity of them, obviously including death. In contrast, those who would, if they were to consume the whole food plant-based diet, they wouldn't have these comorbid conditions, not maybe 1/10 at the most. And then at the same time, that they wouldn't, if they ate this kind of diet, they wouldn't have this. And then in turn, what we learned from the hepatitis B virus, if that applies, I'm convinced it does, we wouldn't have the effect on the disease itself. So I'm going to finish here, just to list for you quickly a resource that we have that'd be quite exciting is at Cornell University. It's an online course. It's been done really well. I'm very proud of it. We've had it now for about 15 years. It's science-based, and doctors can get continuing education credits, and we have a variety of faculty involved in this. That was most recently updated in a publication in 2020. I published this book with my grandson, actually. He's a great writer, and so that came out. In this book here, I'm basically discussing some of the things that we have basically adopted as truths, in fact, are not. If you look at history, you can see where they came from, and you can see where these untruths were developed and why they were developed. So thank you very much, and I'm glad to take questions.
Thank you so much for that very informative presentation. So, and just as a point of fact, watching you in Forks Over Knives is the reason why I became plant-based. So I really appreciate your. So you went over where, your books, and do you have a website that you recommend people go to check out your work, or on any sort of social media, anything like that?
Center for Nutrition Studies, centerfornutritionstudies.org. I'm sorry. No, that's the title. No, it's called nutritionstudies.org. Nutritionstudies.org.
Okay, perfect. Thank you very much for sharing that. And now we're going to begin our Q&A. I'll be asking.
Can I take one break just for 2 minutes?
Absolutely.
Okay, thank you.
Great. Okay, and while he's taking a break, I will share my screen real quickly. Actually, I'm going to hold off, but about share my screen. But I do want to point out the fact that that you can go to our website for a lot of really informative information about the various presenters that we have. We have the schedule for the conference that includes all of the all of the speakers. We also have bios on all the speakers, so you can learn more about each individual speakers, as well as you can go to the website and you can check out the books that the various presenters have. We have not just their latest books, but we have multiple books of theirs. And then as well, and this is great because this is a free online 17-day conference, and obviously it's very difficult to sit and you have other things to do. It's very difficult to sit and watch all 12 and a half hours of each day. So we have the videos the following day that they were presented. We have the videos that you can go watch from the previous days, so you can not miss out on these wonderful presentations. Well, welcome back. Thank you so much. Do you go by Colin? Is that?
Yes, absolutely.
Okay. All right. Thank you. I just wanted to make sure I got that correct. So now we're going to begin our Q&A, and I'm going to ask some questions, and then we'll also turn it over to the audience to ask some questions. And I just want to inform the audience of what they need to do. So real quickly, we don't take questions directly from the chat. What we ask the audience to do is to click on the reactions button, second from the right at the bottom of the Zoom window, and then you'll click on raise hand function in that menu pop up. And when I call on your name, I will unmute you and then prompt you to state where you're from and ask your question. And we just ask that your questions be brief and on topic. And with that, I'm going to go ahead and start with some questions here. So so in the China study, which was obviously a huge study conducted over, I guess, in the 70s and the 80s, do the conclusions that you had come to back then, are they all still the same, or have you learned more information that may change some of the conclusions from the China study?
Yeah, they're basically the same. I mean, of course, as you know, that study was very different sort of design. It was all people. It was located across the country. We call that an observational study, comparing populations, if you will, of villages, which is different from other kinds of studies. You probably know that. So we took a while to analyze the China study, but what it showed was that on the question concerning protein, in China, they consume very little. This is before the data I just showed you. This is back then. But what it showed is that as soon as animal food comes into the diet, and all of its sort of indicators, if you will, that's when diseases start to occur. There are different kind of diseases. Then, of course, the Chinese die of something, obviously. They tend to die of in those days, because this goes back to those data back to the 60s and so forth, they die of communicable diseases, mostly communicable diseases, which we sort of dealt with ourselves in our population years ago, infectious diseases, that kind of thing. So on the question concerning heart disease, cancer, so forth, they were a fraction of what we have. That was in data we collected in the early, well, it's two parts to it, the data available in the 1970s, actually. And then when we did it the second time, this is an update later, we saw the same thing when we combined Taiwan and mainland China. In other words, starting to put animal food in the diet causes problems, whether it's osteoporosis, that was a different kind of study, or whether it was heart disease, cancer, and so forth. And so, yeah, that's what it was.
And have there been follow-ups to the China study to see just how the increase in animal products has contributed to cancer and all these other diseases?
Yes, that's also had access to the Taiwanese data, which are a little more Western, not too much. But yeah, this saw the same thing. we saw the same thing. It's quite remarkable.
Thank you. And what are your current thoughts on the ideal level of cholesterol? I know you during your presentation you had mentioned that that it was more of an indicator as opposed to a cause, but there's a lot of talk of below 150 is kind of heart attack proof. And then some people say that it should be high because we need it for brain function. So what are your thoughts on that and its impact on health?
Well, the level of cholesterol is an indication of lots of things sort of going wrong, if you will, largely triggered by consuming animal food, not enough plant food. Obviously, they go together. So we could talk about a lot of different things, but the ideal levels, so-called ideal levels, are the sort of agreed upon levels by a system that does not. They look at it differently. So it's almost hard to answer this in a short sentence.
Sure.
But when I first got involved in this with our study from China on cholesterol, for example, the average cholesterol in China was, for the whole study, was 126. That was considered to be dangerous territory in the West. So the ideal levels in the West was, as you know, they said if you went below 160, we'd be in trouble. And they named two specific things based on an isolated study here and there. One is we have a higher rate of suicide, so it was said. We have a higher rate of colon cancer. That was nonsense. It was taken out of context. And they would say that we could be as high as 300 level of cholesterol. We're living in the Western country, more cholesterol. In China, they're down to 120, as I said, 126. At first, I could not believe it myself. So we had it analyzed in two more laboratories, one in England, one in China, one in my own lab. And the person I was working with is a gentleman who was the director of the Framingham study at the time. He couldn't quite believe it either. It was that low because we just sort of generally believe it's too low, it's risky. It's so totally untrue. Your question, what do we do? Do we take the range typical that we see in China and go with that, or do we take the range that goes in the West? That becomes a little bit political, to say the least, I have to say. So I don't know to me, the range is just as low as you can, whatever is consistent. I happen to have cholesterol, quite frankly, high by those standards that I just mentioned. I'm around 170, 180, which is not too bad, but that's what it is. And that in turn triggered another consideration I learned about. Some of us have higher than normal levels, even if we do everything right, largely because of our being nursed or not nursed when we were infants. If we nurse, and that came out of a study out of Iowa and some other studies we did in our lab, it came out of this idea that if we start out a baby on mother's milk, that's got cholesterol. That programs us for the rest of the deal. And so at the beginning, this one study I'm thinking of, the babies had a little higher cholesterol levels than those who were on infant formula made out of soy. And so, soy, soy's good. Well, what happened 7 years later from those infants, 7 years later, the ones on the mother's milk said to be high. It really wasn't high. It was like 110. Anyhow, that it gradually increases age up until about 147 years later. The others that were on the lower level looked good at the time. And after 7 years, it went up to 170. So one started at 98, only going to 140. The others starting out with 110. They went all up to one. I said reverse. In other words, the programming in the beginning. So we did some animal studies on that too. Our bodies, consuming the right food at the right time, namely mother's milk. That's part of the activity of the body, sort of adjusting itself for future health. And so we end up with high cholesterol levels because we eat all the wrong food. And
right.
I was not nursed. I had some kind of allergy, so I ended up at a higher level than our kids, who were down around 120. And but that's what it was.
And just as a follow-up to the cholesterol question, given that you mentioned that that cholesterol is really an indicator as opposed to causal agent, does lowering cholesterol artificially through the use of statins, for example, does that actually extend life or produce health?
No, I know that's a very sensitive political topic. I must tell you, I told that to this conference here that you have about 4 or 5 years ago. Kim Williams here beside me. I made a comment. Kim is the head of the heart of cardiology. He said, "No, I got this here, I got that." And so he showed a couple of studies that showed, yeah, it does have some effect. I've looked at all of them that I can. Maybe it has a little bit of effect in reducing the risk, but it's so tiny, not compared to something like what Esselstyn does or what orange does. No comparison. And so that's why I say it's still a little bit contentious at the present time, but yeah, it's little or nothing. And it has all these side effects.
I remember that interaction with Dr. Williams, as a matter of fact. So, so our first question from the audience is going to be coming from Bex. Bex, please state where you're from and ask your question.
Yes, hello. I'm jogging, so I'm going to go to a walk so I don't sound like I'm huffing and puffing. But thank you, Doctor. You are a pioneer, and we all appreciate you. I think that's safe to say that that resonates around the world. My question is, how do you get across to people, even if you cite studies, but like you said, some of the doctors in the peer reviews, they don't want to read it. They don't want to look at it. They're in denial. How do you deal with these types of situations? Thank you.
That is a first-class question. I have to tell you, it's one that's really bothered me a great deal, particularly since the pandemic started, because they were denying, once again, any role for nutrition when there's a very strong effect. And I had the data to have it. They didn't even want to review it. And you're asking me, how do you deal with that? I guess. And this kind of trend has been going on for many years, to be honest about it. Nutrition has been denied have anything to do with heart disease and cancer and so forth and so on for all that time, primarily because they're considering nutrition to be a function of one nutrient at a time and one target. And they like to keep drugs. That is drilled in our heads so much from the policy level at the national level, if you will, all the way through schooling. And it's become just a common knowledge. That's why I said it's unconscious denial of what might be the truth. And I'm actually writing another book right now, just about done, on just exactly this question. Why have we gotten in such a rut, collectively across the nation, across the world, with this idea of denying what can work and what can't work? I will tell you just really briefly what the problem is. Reductionist science, where you can one thing at a time, it sells, it makes money. Okay? Nutrition does not. It's that simple. I'm sure that some people are going to get annoyed at me for saying this, but at our government level, and I was intensively involved in some of the policy development things years ago for about 20, 25 years. The USDA, the Department of Agriculture, they're protecting the livestock industry. The Department of Health and Human Services are protecting the pharmaceutical industry. So the agriculture department lets us eat the wrong food, in fact, encourages it. We get sick, more patients. The other department is sitting there ready to go with drugs. Lyndon Johnson knew that way back in 1969, and the thing was never published at the time, when he was speaking to some CEOs of the pharmaceutical industry. So I really had, I have to say, a lot of experience at the policy level, as well as the laboratory level, and speaking to medical schools to see this unfold. And it is very sad, and it's quite frankly, it's scary, because what is happening now, and during that time, especially since 1971 until the present time, they took away the one instrument that I had, a lot of my colleagues didn't, and that was academic freedom. Universities are supposed to be places where you can go and speak your mind, and you don't get fired because if you say something that's not popular. I had academic freedom from the time I was in my early 30s, quite young. So I've had the benefit of saying what I feel like saying. I have to tell you, now that's almost gone. It was diced and sliced from in a formal study a formal analysis from 1980 to 2010, when the Supreme Court decision, Citizens United, was passed. In other words, there are forces in our society. I know this is terribly contentious, but there are forces, large forces in our society that basically control the information we get on health so they can protect the industries that are making money. That's the shorthand. And so I'm open to whatever anyone else can add to the argument. Disagree with me if they like. But we got to deal with that question. Who's providing the information to the public? I say this program right here. I'll put a plug in for this program just for that reason alone too. Reaching out to get opinions going. We don't have that often enough these days. And so there you have it. I could talk all day long and night on this subject, but I'm really very upset because I have seen what has happened during the pandemic play out over years. I probably shouldn't say this, but I'll say it anyhow because I say what I believe, but I did not get the vaccine. And people thought it was crazy, especially at my age. My wife or myself. And then we lost our minds. Well, I was basing it on what I knew about biology, about biochemistry, about virology, as a matter of fact. So we were on, and finally we got tested positive. It was just last October. No problem. We didn't get sick. We didn't have fever. We didn't have any headaches. A little bit of coughing. Went on for just feeling a little bit of flu-like symptoms for 6 to 8 days. That was it.
Wow.
So people don't like me to say that. That I'm shooting my mouth off when I have no reason to do that, supposedly. But it's part of my story. It's part of my story.
Do you find that talking about the state of doctors being receptive to this message? Do you find that that's gotten better at all?
Yes, and we just were talking about yesterday. I have a great respect for the medical profession, of course. I have a lot of alliance and association with a lot of good folks there. That's not the issue. I feel sorry that they're not taught nutrition. But it's interesting. There's a couple of polls that were taken one time in the late 50s when I was at veterinary school, and another time in the 70s. They were asked, what's the principal motivation to go to med school? Because I considered it myself. And the principal motivation is to, and there's nothing wrong with this. I don't want to bring up this issue, but it was income producing potential. 80-some% listed that. One case was 83%, the other was 86%, really quite good agreement. And the other group, what they're just weren't that concerned about making money. They were just interested in getting into this area. So you make a lot of good arguments for, we need funding, we need money to make that system work, if you will. Fair enough. I'm a free market guy. I'm not going that far. And so on the other hand, we just have to face the facts. If we choose the kind of medicine that relies on the use of drugs and those kind of instruments, those kind of techniques, it's going to be much more expensive. And we'll keep on eating wrong food. That's not in our interest. So now we have these terrible records, on mortality. We can look back and we can see the price we've been paying. It's awful.
And you had mentioned your inability to get some of your articles published, the peer-reviewed journals. What medical nutrition information do you consider accurate and credible, and what sources do you consider accurate, and what sources do you consider inaccurate? Like, where should we be looking to get our credible information, and where should we avoid?
Gosh. The leading journals, JAMA, American Medical Association, New England Journal of Medicine, they're two of the big ones, obviously, for the United States, and Nature, Lancet, and so forth, British Medical Journal. I mean, they're leading names, and they work hard, let's say it that way. They work hard to ascertain, they make sure that these articles being submitted are properly reviewed. And, they make sure that that biases are declared, if you will. And so all on that account, They do a really great job. They've been doing a great job. The problem is we're all living in this paradigm, which is part of the history that I got fascinated with. We're living in a paradigm where we came to believe that solving health problems was doing one thing at a time, called reductionism. In the earlier days, in the 1800s, when that started, that was called local serious disease. And so that became the industry for obvious reasons. And then they got trained that way. And so I would argue that a lot of good friends, a lot of people who trained well in medicine are doing the best they can. They're very fine people. That's not the issue. And in some cases, they got some drugs that in the short term, might help. They do help. But you use them as a technique for long-term health in place of, let's say, food. I feel very strongly about that. That's not a good path to follow. If we just do the thing right in the first place when we're born and on going forward. My wife and I also did that too. I didn't start really until I was in my early 50s. And so I was probably too late. My wife was late 40s, but she had a lot of cancer in her family. My mother passed away at 51. My dad passed away of heart disease at 71, even though he's slim and he was a farmer. So I got heart disease on my side. She got cancer on her side. Brothers in their 50s. We obviously took this seriously. And so now we don't take drugs. I'm 89. I shouldn't knock on wood, obviously, but I just, you think about it personally, obviously, and I was taking what we were looking at quite seriously. I don't want to, see that early demise. And so she got at the time when she was just getting around to doing it right. She was diagnosed with advanced melanoma, very serious. And she was told she was going to have to surgery to remove her lymph glands because the cells had migrated to her cells and her leg groin. Anyway, they're going to remove the lymph glands, if you will, give her drugs, long drugs. Well, we knew enough then. She knew enough too. She said, I'm not doing it. The man freaked out. He got very, very angry. And so she had that was now 20 years ago with no problems. And so, and my dad died 71, his brother 58, heart disease, and they don't have any heart problems. I mean, that's a case, what is that, a case or two? So I want to be careful about this, just to make it clear. That's just, so for others may disagree, they may, I don't do it that way, that's fine. But I'm just talking about it in the context of what we were willing to do personally. That was in turn related to the research that I was also involved in.
So you wrote a book called The Low Carb Fraud. Yet today there are books that proliferate on keto that are very popular. Can you explain generally about that? Why you're against the low carb diets, and why do these diets still persist?
Well, that started out with Dr. Atkins in 1973, the so-called Atkins diet, as you know, and subsequently then it was named various and sundry things: the paleo diet, low carb fraud, this and that, a few other names from time to time to keep it alive. And what happens is that they, at that time, Atkins was concerned that at that time there was some noise being made in the health community that we shouldn't eat so much fat in particular, high cholesterol diets, and we maybe should lean a little more to the plant-based diets. I was on the original studies on that was National Academy of Science on cancer, so I watched this grow. There was a reaction against, or even hinting that eating more vegetables and fruits is a good idea. Strong reaction. He got in that big time, and then he was, that was in the way. He said it's okay to eat some cholesterol and fat and so forth, and so no problem. And and then he switched to that was high carbohydrate, low fat. He said it's the carbohydrates the problem. Well, what he was really talking about, he didn't explain it very well. He was talking about free sugar. Sugar is not the best, of course, but carbohydrate in plants naturally, that's great. That's the main source of energy. Then he sold the book in 73. And then it took on, it got sort of named again, and other authors came up and named it various other things, all dealing with the idea of low carb. When we consume low carb, we start to break down some fat, and we lose some weight. For those who have weight, if they go on a low carb diet, they will lose almost a guaranteed. They will begin to lose some weight, and quite a bit at times. That's good. They say, that's for me, I'm going to stay there. But the problem is, if they stay there, they usually don't. They don't. But if they stay there for, let's say, more than 6 months, then they're going to start paying a price. Now they're back in consuming a high animal protein, high fat diet, and they will pay the price. So they see the short-term benefit, if you could call it that, and who doesn't want to lose weight? That's the issue. Atkins himself died of a heart problem when he's 73.
What you said after 6 months, they start paying the price. What do they start seeing after 6 months?
I make that point, that saying it that way, because if you start looking at the level of risk for getting heart disease, for people consuming different amounts of high fat, which in turn really was animal food for the most part. If you saw that, if you look out 6 months, 8 months, something like that, you could see that these differences between people consuming different diets, you can see that the people consuming the Western kind of diet, animal protein, high fat, if you will, you can see the lines are starting to separate. And so the risk starts to occur. I mean, it's a judgment. It's a judgment call in my case. There's nothing specific. But
Okay.
by the time they get to, the age when many people die, 34 years out, then you see a big difference.
And a lot of people believe that eggs are the perfect food, and then if you want to avoid the cholesterol, you eat the egg whites. They believe that they're good for us. Obviously, I know what you believe, but why are they bad? And are they just another animal product, or are they specifically bad? And what does the general science show?
Well, egg whites, there's a lot of protein, as you know. So animal proteins in general all are about the same. Slight differences, but they're far different from the proteins of plants, right? So when I speak of animal protein, I'm speaking of egg whites as well. Because if you, in fact, egg protein is considered to be one of the highest quality proteins, if you use that metric that I briefly discussed. And it's the same as casein, egg protein, obviously eggs and chickens, and casein in milk and meat and animals. So to talk very specifically about what's the difference in egg protein and egg yolk, if you will, my judgment on that, and I liked eggs, by the way, we had chickens as well, but my judgment on that is just looking at the average data that have accumulated over time. And there is some evidence that I know has been published, I don't know what's been reported, that egg themselves is associated with more colon cancer. And there's arguments being made that's somewhat impressive. So I mean, the whole idea of not eating animal protein when we don't need it, we don't need any, we can survive really well. In fact, survive a lot better, not having any. So I'll go I'm not trying to be a purist, to be honest about it. I'm just simply saying, I don't even like the word diet. I like the word nutrition, the whole food nutrition. And all I'm saying is that everything that I see, like those lines, those regression lines, and everything else we do, it's all bad. It starts out from the day zero. And, you may not see these results, these differences right away. And I know too that some people can, they can manage a little bit of doing the wrong thing. If we're good long life, that happens. We're talking about statistics. But, I want to be in the crowd where there's a 99% chance that, I'm right. Then living in a crowd where, I'm only half, let's say, or 50-50. So the data for me from so many different directions is so persuasive that I wouldn't do anything different. And now we go with the environmental thing. That's another issue, really big issue. That the environment, that's probably the biggest of all. We got some serious problems. And 80%, well, between 70 to 80% of that information or that problem is due to livestock. We're setting up a new program in Dominican Republic right now with our organization. My daughter's the president of this nonprofit where we just got a bunch of land that was actually devastated by deforestation with cattle being raised for the American market. So we will show how that can be changed.
Do you want to give a shout out to the name of that organization that your daughter is running?
Yeah, it's CNS, the Center for Nutrition Studies. You can find out about it. They partnered with another nonprofit in the Dominican Republic, and it's just now getting off the ground.
All right, great, thank you. So I'm going to have an audience member ask a question. Eileen, please state where you're from and ask your question.
Hello, I'm from New Jersey. Dr. Campbell, thank you very much for speaking up about the COVID vaccine. I had a question about the China study you had where the Chinese people died, not of cancer, of course, but of intestinal obstruction. And that really intrigued me. What is that all about?
I don't know, to be honest about it. That was the designation that the Chinese used to classify causes of death. And so I don't know.
Maybe poisonous food or
I don't know what it was.
Okay. Thank you.
All right. And we have got one more question coming from Bex. Bex, please go ahead and ask your question.
Thank you again, Doctor. We really appreciate all that you do and who you are. Knowing what we know, that it's all for profit, and having your knowledge and your background, do you see a plan? Can you help the next generations take this forward so that perhaps in some of our lifetimes, we will see the end of the subsidies for the junk and the things that are killing us? Thank you.
Yeah, I have a plan. I always have plans. And the question is execution and whether they're going to be done or not. In terms of the information that I'm familiar with, coming all the way from being a farmer to where I am now, I just became so persuaded that whether the animal protein is not a nutrient, I just have to be, it's not serving us good. That's that simple. So if we can just educate people on that for starters, and then also equally importantly, educate people on the value of plants. And know this is important. My Italian friends have learned this and really quite well. They have actually kind of spanned their whole country. I've been there several times lecturing. And so they go around and tell them all around Italy about this information. They were then taking a group of people at times, putting them into a program called Jumpstart, a word that my oldest son had used. Take a group of people with disease, possibly, let them eat it for 10 days. And most of the people felt great. They saw remarkable changes. And I have two sons who've done that. My oldest son, who wrote the movie Plant Pure Nation, and now he's made another one, Food for Freedom, which just got the Diamond Award, I might say, in the Los Angeles Film Festival. But in any case, one of them is a filmmaker and doing that kind of thing. And so when they do these 5, the 10-day things like this, they see what others have seen. Dr. Esselstyn's done it on a fairly regular basis, this kind of thing. His son, Rip, has certainly done it, and others, friends of mine. We always see these remarkable changes. And you would think, wow, these are sick people and they feel so good after that. And then they fall off the wagon. And only about 10% of them stay with it. Coming back to my Italian friends, they were aware of this too. So here's what they did. They put people on, a group of people on for 9 days. There was sort of, not too good a health. On 9 days, they felt great. So then they asked them, would you like to do another 15 days? And everyone said yes, because they're feeling good at that time. And so they did it 3 more times. By the time that, 15 days and 9, that's 69 days. At that time, they asked him, would you like to do another 15 days? I mean, they were already there, permanently changed, never going back, which demonstrated a principle of biology, essentially. And that is we tend to eat to a great extent what we like, obviously. We get used to it. We embellish it with salt, sugar, and fat, which are not necessary, and that just sort of feeds the addiction we have. In this case, these people had gotten to the point, and I think it's around 2 or 3 weeks for most people, maybe longer. People have gotten changed. When you get to that point, you don't want to go back. We just don't want to go back. And so to answer your question, we could get that sort of told, and people adopt it, and also recognize why we were getting the wrong information. That's the other part of the story too. As I say, my oldest son has a film out right now that's really just won the award called Food for Freedom. And that's kind of exciting because what they were doing there, they went back to people who tried it, and then they left them alone, went back 6 months later, something like that, and got from them whether they stayed with it or not, and got some, explanations. So just have to keep plugging away. I wish we could think of something on a grand scale, like, outlawing deforestation or something like that. I don't know. It's tricky business.
Thank you very much for that explanation. So another question, and obviously animal products, we've had this discussion, is absolutely, directly correlated with increases in disease. Is there any benefit to this idea, not that it's good for you, but is it less bad for you if your beef is cow fed? That's become very popular. Is there any science that shows that? I'm sorry, grass fed, not cow fed, grass fed. Is there any benefit to grass fed beef as opposed to the standard beef?
No, there isn't. I know that the fellow who started that at the time, he was given a lecture twice. When somebody asked him the China study, he shouted it out to him and said, "Don't read the China study." It tells me a lot. And he's not himself. He was not a scientist. I won't use his name right now, but he's not a scientist. He's a writer for the New York Times. And so that idea sold, pretty well. Grass-fed. We had grass-fed animals ourselves. They weren't feedlot. And the small farm operations in the years gone by were mostly grass-fed animals. What changed was the big factory farms. Because they're now, making thousands of animals in one operation, being fed that. And so, but there's no evidence that original argument was based on one narrow little idea of omega-3 to omega-6 fats. And he was arguing that animals fed on grass lot, they were better quality meat, if you will, and fat in particular, more omega-3, which is anti-inflammatory. Omega-6 is pro-inflammatory, and you get a better ratio. That sounds like, it's going in the right direction. But they all have the same protein. Set aside the fat question, they all have the same protein. There's no difference. So we need to do a grand experiment to check me out on that, but I think the data are so powerful.
So we have about 2 minutes left, if that, not maybe like 1 minute left. Is there any parting thoughts that you want to leave us with in the next minute or so?
Yeah, I'm very enthusiastic, of course, after spending all these years of at least leaving behind a message that, not just for our own personal health, but for the larger sphere of living, for societies. We got the planet may be at risk. The Earth is at risk. And so much of it relates to just choosing the right food. And the biggest problem we have, I have to say, is probably economics. That is to say, the drug industry, the food industry have a lot of people working for them. And we can't just shift like that. I'm a free market guy. But at least we can have the conversation to offer this information to the public at large so they can have the choice. We got to stop this business of trying to tell them the opposite. So we this is a matter of freedom of speech, I would tell you, for sure. And just having the will to tell it like it is with science, with good evidence.
Great. Well, thank you very much, Doctor. We really appreciate your time, and your impact is immeasurable. If we can unmute the audience, and I just want to thank you one more time for this.
Thank you, Dr. Campbell from the Netherlands.
Campbell did it his way.
Thank you.
Thank you.